Analysis of a structure frame example. The step number one is to find the reaction at the different support points. So reaction forces. So here you have reaction. So it is supported at B and A. So we're going to do the process to find the reaction forces at these different points is to remove those joint or connection or support at both support point and replace them with the appropriate forces. So you got the rolling contact at B, so there will be only horizontal reaction component at B, so you will have only V horizontal. And then at A we had pin connection, so there will be a vertical component a V and also a horizontal component AH. Now in this scenario we know that there was a rolling contact on the left side, so the reaction will be to the right side direction, and then therefore the reaction at horizontal reaction at A will be to the left direction, because we know we're going to assume in the direction where they are. Now, after you draw the free body, then to find the reaction forces, we need to take moments. So you have three equations to work with. So summation of all x forces is equal to 0. Summation of all y forces is equal to 0 along all y-axis. And also the moment with respect to any point is equal to 0. So now in this scenario we can do first, doesn't matter which one you do first, so we can do summation of Fy to find out that the vertical component at A. So the vertical component at A we assume upward direction, which is positive, minus all the other forces that 12,000 pounds this crane is carrying or moving, that is going downward, minus the weight of the boom, which is 2,400 pounds, minus the weight of the brace, which is 1,800 pounds, minus the 3,000 pound post weight, and everything summed to 0. So they are acting all downwards. So then the vertical component at A I found 19200, and that's a positive force upward direction. Now we can take at moment at C, moment at A or B, it doesn't matter. As you have seen before, if you take moment at one point, you're going to find the reaction forces at the other point. So it doesn't matter which one and with respect whether B or A. So let's take moment at A. So if you take moment at A, for the 12,000 pound, it's going to do a counterclockwise moment. So this 12,000 will do a counterclockwise moment like this. So we can do, so that will be a positive moment, 12,000, and that is 32 foot away from A. So the line of action of this force, so that's 32 feet from A, that's the line of action. Then plus 2,400, that boom weight will also do a counterclockwise moment, which will act in the middle of the post. So that's going to be 16 foot from A. So that's going to be 16 foot. Plus the 1,800 pound, which will be 12 foot away. So the middle of this brace, that's why the load weight of the brace will act. So total 24 foot. So this distance will be 12 foot from A. So 12 foot, and minus that the horizontal component at B will cause a clockwise moment with respect to A. So that's going to be a negative moment, BH, times that is total 40 foot from A. So 40 foot from A, everything summed to 0. So then we can find that BH, I found it 11,100 pounds at B. That's the horizontal reaction at A. That's going to be the exact same as this AH, because there is no other horizontal component. So the AH will also be that, but it's going to be exactly the opposite direction, so that everything gets balanced. So H is going to act to the left direction. So this is the first step. So we found all the reaction forces. We free the body, free the entire frame from both support point A and B, and then we find the reaction forces. Next, we're going to, so the next step is to, this is the same figure, I just redraw it so that you can see when I work here. So the next step, or step number 2, there is actually only 2 steps. So this is the step number 2. What you do to analyze the frame is just free one of the member of the frame. It doesn't matter, free one of the member. It doesn't matter which one you free, just free one of them. So we get 3 members here, C, D, F, D, E, and also the post member. Let's free that C, D, F members. So here we got the F. At F we got 12,000 pounds. This crane is moving around that load. And at D, so we are freeing at D and also at point C. So we if we free that, similar concept that you apply once you free, then you assume all these different points, they are pin connections. So they will have both horizontal component and the vertical component. And if we don't know the direction, we'll always assume in the positive direction, just for the consistency of the of our solving strategy. So we're gonna do a vertical reaction at point D as well, and then we'll assume a horizontal component as well. Now here you see we have total. We also need to consider the weight of the boom, which is 2400 right here. So that is all the load. So this is the complete free body of that member CDF. So we free this member and draw the free body, so it is complete now. Now we can apply our 3 equations. So summation of Fx 0, summation of Fy 0, and moment with respect to any point is also 0. Now look, you have 4 variables here, 2 variables at point D and 2 variables at point C. So we won't be able to solve all 4 variables from this free body. So we have to do the next free body, and there we'll be able to solve everything. So here in this case, if we just simply so one thing we can write that DH plus CH will be equal to 0. So that is summation of X in one equation. And then we can take moments at any point. So we can say, let's take moment at point C, all moments sum to 0 to find out the one of the force at point D. So if we take moments with respect to C, so the 12,000 pound will do a counterclockwise moment, which is positive, and that is total 32 foot away from C. Then also this 2400 will do a counterclockwise moment, again positive, which is 16 foot away from C, minus this dV will cause a clockwise moment with respect to C. So that's going to be minus. So dV times, and that is 24 foot away from C. Everything summed to 0. So if you solve for dV, I found that plus 17600. So this is the vertical reaction at point D. Now if you apply our next equation, summation of Fy is equal to 0. So this was our summation of Fx is equal to 0, equation number 1. This is our equation number 2. This is our equation number 3. So then if we do Fy, summation of all forces, so then the 12,000 acting downwards, so that's negative. The 2400, the boom weight acting downwards, that is negative as well, plus this reaction at D is acting upwards, so which is positive. That plus the CV, everything summed to 0. So then CV, I calculated that minus 3200, 3200 pound, but it is negative. What I would like to do next, before I free the member DE, I would like to redraw the free member with our appropriate forces. So this is what I would like to do. So it's a good practice. One of the common mistakes in the exam is actually having the signs right. That is the biggest problem. So by redrawing all our calculated forces, so 12,000, so we know that the D, we found the DV was vertically upward, 17600, and then we have the DH. We still don't know DH, so we'll just have that, leave it there as it is. We'll have the C, we found it actually downward instead of the upward direction, so I'm gonna have like that. So that is our CV, vertical component at C is downward, and we still don't know that CH, so we'll just leave things like this. So, and also we have that 2400 pounds boom weight. So now we have all the appropriate direction for forces at both C and D. So what you're going to do next is to remove the next associated member. So you can either remove the post AECB or remove DE. It doesn't matter. So let's remove the post DE. So now next step is to free DE. So that is our next step. So we're gonna do somewhere like this. So this is our DE, and the weight of the DE is going to act in the middle, 1800 pounds. That's not gonna change. One thing you have to remember, that the reaction, when you are considering that CDF member, the reaction at point D was acting upward. So the associated member will have the exact same force. However, it's going to be exactly the opposite direction. So for the DE member, that same 17,600, it will have the exact same value. However, it's gonna act exactly the opposite directions. So in any joint, you can imagine, let's say you're standing on the ground. If you look from the ground perspective, the force will be in one direction compared to if you look at from your feet perspective. So exactly the opposite reaction direction. Now we're going to keep that DH, which you don't know, is still in the same direction. And then so then the EH, we need to have this reaction at. So then, as you can see, the reaction at point D of this DE member is going downward, the weight going downward. So then, just to balance that, the vertical component at E must be equal to the two other forces coming downward. So very simple. What we did here is simply summation of Fy is equal to 0. That's the principle we applied. So basically all the load coming from upward will be balanced by the point E. So the total is 19400, and that's the positive force. So we know the vertical component, horizontal component, we don't know the direction, so we can simply assume, because we don't know, we can assume all in the positive direction. Now we have two unknown, DH and DE. We can take moments at E, or moment at D, it doesn't matter which point you want to take it. Let's take moment at point E. So summation of all moment counterclockwise 0. If you take moment at with respect to point E, so that's 17,600 will cause positive moment with respect to E. It's going to do a counterclockwise moment, and which is 24 foot away from E. And then also that 1800 will do the same counterclockwise moment. However, it's only 12 foot away from E. And also that DH, the horizontal component, will do a clockwise with respect to point E. So that's going to be minus DH, and that is 24 foot away from E. Everything summed to 0. So then DH will be plus 18,500. If the DH is plus and is acting in this direction, so if that has to be balanced by EH, so it's going to be exactly the opposite. So either you say is in the left direction to the x-axis, or EH is minus 18,500. Now next, what I would like to do is to redraw that DE member with the correct signs of the forces. So our assumed direction was one of them was negative, so let's redraw the DE member. So we're gonna do right here. So I'm gonna redraw that DE member. So right here, DE member. So we got, if we redraw that, so we found that DH was 18500, and then here we got the EH in this direction, the horizontal component 18,500, and then the vertical component at E was upward direction, was 19400, and then the vertical component at D of the DE member was downward direction, which was 17600, and the weight was also downward as well. We also would like to redraw that the CDF member. So now we are almost done with this problem. So the CDF members at point C, so here we got the 12,000 pounds, and then the weight of the member. So let's say this is our C, this is F, this is D. So at D, dV was, it's in the upward direction for the CDF member. This is our DE member, and then the horizontal component we found at for the for this DE member, we found the horizontal component in to the right directions. For the CDF member is going to be exactly the opposite direction. So it's going to be basically to the negative direction, minus here. So then the horizontal component at C is going to be in the right direction. And then the C vertical was 3200. Now we got almost everything to verify our analysis. So the way you verify, you do the post. So the other member, the third member here, which is A. So this is the member A. So you only need to, I'm going to use this picture here. So at C, as you can see, for the CDF member, at C, the reaction was vertical reaction was acting downward. So for the AEC member, it's going to be exactly the opposite, so upward direction. So that will be the 3,200 pounds in upward direction. Now CV horizontal was acting to the right direction, therefore it's going to be to the left direction. So that's going to be 18,500. Same thing. Now at E, the DE member, the EH horizontal was acting to the left. So now for the other member AECB is going to be to the right direction, so which is 18,500. And then at E, for the DE member, the vertical reaction was acting upward, so it's going to be exactly the opposite direction with the same force, 19,400. Now if you balance everything, you will see that all the forces, external forces, will be exactly the same as the internal forces. So for example, that 19,200 at reaction at A plus the weight of the post is going to be the exact same as the internal that we have calculated, which is now this is so the 19,200 pound acting upward plus the 3,200 is acting upward as well. So this will be exactly the same as all the forces acting downward, which is 3,000 pound weight plus that force we calculated at point E, which is 19,400. So this is going to be the exact same. So this is verified. You can also verify that. You can see that 1,850 to the left, 18,500 to the left, 18,500 to the right, and also that 11,100, 11,100. So if you do all this calculation correctly, you should be able to verify using the final member of the frame. So just to summarize, so going back, first you have to draw the free body, find the reaction forces at each point. Once you find the reaction forces, then free one of the member, doesn't matter which one you free, and then complete the free body diagram by having the reaction forces as each point, for example D and C, and then try to calculate the unknowns. And if you don't find the unknown, go to the next, free the next member. Now before you free the next member, I suggest you redraw that member you freed with the appropriate force direction, because sometimes the force direction would be the opposite, like this one. And then you do the free the other member, draw the free body diagram. One thing you must remember, that if the member CDF had the D vertical force upward direction, the associated member will have the reaction at the same point, exact same reaction, but it's going to be the downward, the other direction, so that it balances everything. And you just keep following this step, and by the final member we'll be able to verify whether you have calculated it correctly or not.